Welcome to the Museum at MFIT's Material Evidence Assessing Risk in Museum Collections Virtual Symposium. My name is Tania Melendez Escalante, and I am Senior Curator of Education and Public Programs. It is my honor to introduce Dr. Melissa Tedone, who will present the talk, If Books Could Kill, Toxic Textiles in 19th Century Euro-American Bookbinding. Dr. Tedone is Head of Library Materials Conservation at Winterthur Museum, Garden and Library, and affiliated Associate Professor in the Winterthur University of Delaware Program in Art Conservation. We thank the U.S. Institute of Museum and Library Services, as this project is made possible by a grant from IMLS. We hope you enjoy the show.
Hello, my name is Melissa Tedone, and I will be speaking today on behalf of myself and my research partner, Dr. Grozy Rayburn. This living land acknowledgement was crafted by the University of Delaware in consultation with the tribal leadership of Patuxet, now known as the Delaware Bay. To learn more about the ancestral caretakers of the land on which you live, please visit nativeland.ca. The hardcover books that we know today are often bound in cloth, but in the 19th century, book cloth was a new material that revolutionized the book trade. More affordable than leather or parchment, more durable than paper, book cloth facilitated the development of a new genre of book. Affordable retail bindings, some made to order, some ready to purchase off the shelf. These books are often called publishers' bindings. Whether plain or highly decorated, these cloth bindings catered to an increasingly broad demographic of readers and drove big profits for publishers. Book cloth was invented in England in the 1820s and was commercially available by the 1830s. With the exception of a single rival mill in Germany, England monopolized book cloth production until the end of the 19th century, when mills in Delaware and Rhode Island began to produce book cloth in North America. Throughout the 19th century, books were still bound mostly by hand, but with the increasing assistance of hand-operated and steam-powered machinery. 19th century publishers' bindings were mass-produced in binderies like this one, Wesley and Clark's, a large establishment in London that bound thousands of books per week for dozens of different publishing houses. As you can see in this illustration, the work was accomplished through a division of labor to speed production. Our investigation of potentially toxic colorants used to color Victorian-era book cloth began with this book, which came to the Winterthur Library Lab for conservation treatment in early 2019. Our discovery that this bright green book cloth was colored with arsenic-containing emerald green pigment led to a series of pressing questions. How common is arsenical book cloth? How much arsenic is present in a single binding? What risks do these books pose to library staff and patrons? What other toxic pigments may have been used in book cloth manufacture? A binder's ticket indicated that Winterthur's rustic adornments had been bound by Wesley and Company, a later partnership that developed from Wesley and Clark's, the bindery that we saw in the previous slide. Wesley and Company was also a highly prolific book bindery, so it seemed likely that there could be many more books out in the world bound in emerald green book cloth. We set out to find them and to better understand book cloth production. The pigment copper acetoarsenite is known by many names, as you can see here. Historically, many of these terms have been conflated, for example, using Sheila's green and Paris green interchangeably. However, Sheila's green actually refers to the compound copper arsenite, which is a more yellowish green and vulnerable to light damage. The more color-fast emerald green, or copper acetoarsenite, was invented at the turn of the 19th century and began to be commercially produced in Schweinfurt, Bavaria in 1814. After analyzing hundreds of green books, we have found only emerald green, not Sheila's green, as a 19th century book cloth colorant. So copper acetoarsenite is the arsenical pigment I will be referring to throughout this talk. The many questions arising from the emerald green book cloth on rustic adornments catalyzed an ongoing research project now widely known as the Poison Book Project. We began with a collection survey of Victorian era English and American imprints in the Winterthur Library's circulating and rare book collections. In these images, interns Layla Huff and Sarah Leonowitz are conducting elemental analysis using a portable X-ray fluorescence device. XRF identified the presence of heavy and transition metals, and we then followed up with Raman spectroscopy to identify the molecular compounds. Altogether, we analyzed over 500 brightly colored books in a rainbow of colors, approximately 350 of which were covered in green book cloth. The most toxic elements we identified were arsenic, chromium, lead, and mercury. 38 of the 350 green books were found to contain arsenic. Over 50% of the total books tested contained lead. We initially focused our research on arsenic as by far the most acutely toxic of the elements we identified. We're now working on chromium and lead, and we plan to continue with research into mercury in the future. We've essentially been working in descending order of toxicity. Victorian book cloth colored with organic green dyes tend to present with faded and muddy hues. So we primarily select deep and vibrant greens for our ongoing analysis. We have found that the majority of deep or bright green Victorian book cloth is pigmented with chrome green, shown here on the left, in contrast with the more vivid emerald green on the right. Chrome green book cloth appears to have been in use from the 1840s through 1900, while emerald green book cloth has been identified on books printed from the 1840s through the early 1860s, with the most frequent occurrence in the 1850s. Chrome green is a color made up of the yellow pigment chrome yellow combined with Prussian blue. Chrome yellow was quite expensive in England until the 1880s, so many of the earlier chrome greens are a deep forest green thanks to a smaller proportion of yellow to blue colorant. When chrome yellow became more affordable in the 1880s, bright and olivey greens, deep yellows, and vibrant oranges became popular book cloth colors. While neither chromium nor lead are as acutely toxic in small doses as arsenic, book cloth colored with lead chromate does present a double threat, and chronic exposure is a concern. So you may be wondering at this point, what makes book cloth a distinct material? Luxury fabrics like silk and velvet were occasionally used for bespoke book bindings in earlier centuries, but these cloth coverings abraded, frayed, and faded easily. The first moderately successful book cloth experiments in 1820s in England were a collaboration among bookbinders and drapers living in the Clerkenwell neighborhood of London. Glazed calico seemed promising, but the glue used to adhere the cloth to the cover board seeped through the weave and left unsightly stains. Heavily starching the cloth seemed to help. Over the next couple of decades, bookbinders tackled additional problems. Plain weave dyed cotton cloth lacked visual appeal as a book covering, and since most books were stored on open shelves, the colors faded quickly. So book cloth producers started putting colorants directly into the starch slurry that coated the cloth. They bulked up this slurry with additional binders and opacifying agents to create a more robust coating for the book cloth. They also experimented with embossing the cloth with a variety of eye-catching grain patterns. Some grains, like the one shown here on the left, mimicked leather. Others, such as the one on the right, had a pleasing geometric quality. By the second half of the century, the backfilling machine pictured here on the right was in use by dedicated book cloth manufacturers to apply a pigmented starch slurry to bleached cotton cloth, producing book cloths that were brilliantly hued and fairly robust and durable. Here are 3 green book cloths from the Victorian era: an organic green dyed book cloth on an 1829 binding, an emerald green book cloth on an 1857 binding, and a chrome green book cloth on an 1862 binding. We examined these book cloths using a Hyrox 3D digital microscope and captured these images at 100 times magnification. On the left, you can see how the green dye penetrated the fibers of the cloth. Contrast the book cloth on the far left with the emerald green book cloth in the middle image. This photo clearly shows how the emerald green pigment is contained within the starch coating and the underlying cloth is undyed. This image also shows how friable the emerald green coating is. You can see how it has shattered and spalled from the surface of the cloth, especially at the high points of the weave. Finally, in the image on the far right, we see a chrome green pigmented coating, which exhibits some micro cracking, but appears to remain tightly bound to the underlying cloth overall. The seemingly friable nature of the emerald green book cloth worried us, so we set out to measure the amount of arsenic present in the book cloth. We took a destructive sample of the book cloth from underneath the paper paste down covering the inner face of the backboard. We also wanted to measure how much arsenic might be offsetting when the book was handled. So we did a swipe test with dry cotton pads and cotton swabs to simulate handling. These samples were all sent to the soil testing lab at the University of Delaware for quantitative analysis. The results confirmed both the toxicity and the friability of emerald green book cloth. This single average-sized octavo book binding contains several times the lethal dose of arsenic for an average-sized adult, although the book cloth would need to be ingested to have a fatal impact. Perhaps more worrisome, the friability test showed that the amount of arsenic that easily offsets during handling is several times greater than the OSHA exposure threshold for inorganic arsenic compounds, even though this offset is invisible to the naked eye. We are currently awaiting results from friability tests conducted on chrome green and chrome yellow book cloth. While chrome green can occasionally present as a color similar to emerald green, most chrome green bindings are a deeper shade of green, as you can see here. In all of the emerald green cloth bindings we have identified, copper acetoarsenite has been the only colorant detected. So emerald green book cloth presents a remarkably consistent, vivid hue across bindings. Emerald green is light fast, so it doesn't fade. However, it is susceptible to sulfurous air pollution, which causes the pigment to darken. Most of the emerald green bindings we have seen with this kind of damage exhibit darkened spines, while the book cloth on the front and back boards remains a vivid, unsullied green. This makes sense if you think about books sitting on a bookshelf with their spines exposed to the air, but their front and back boards pressed against neighboring books on the shelf. Emerald green book cloth is so consistent in hue that we were able to create color swatch bookmarks to assist other institutions and collectors with visual identification of potentially arsenical green book cloth. On the left, you see our original bookmark. We printed 1,000 of these and sent them out upon request to institutions and individuals all over the world. On the right, you see our second version of the bookmark, which we updated based on a focus group held with half a dozen institutions who had used the bookmark to identify potentially arsenical books in their collections, and then followed up with instrumental analysis to confirm the presence of arsenic. The updated bookmarks were printed in June 2022, and I'm pleased to say that requests for them continue to roll in. Here are some sightings of our first bookmark out in the wild. These are screen grabs of Instagram posts from bookmark recipients. Visual identification of emerald green book cloth using the bookmarks is, of course, subjective and therefore only modestly reliable. Whenever possible, we encourage following up visual identification with instrumental analysis. We're grateful that so many other institutions have been inspired to identify emerald green bindings in their own collections and have generously contributed their data to the Poison Book Project. The opportunity to connect with colleagues across the country and around the world has been one of the most rewarding aspects of the project. Our team at Winterthur has performed XRF analysis for other regional institutions, sometimes in-house and sometimes out in the field. Pictured here on the left, interns Amani Johnson and Tempe Stewart are helping to collect data on site at the University of Delaware Morris Library. On the right is a photo of colleagues from the Philadelphia Athenaeum who brought a few suspiciously green books from their collection to Winterthur for analysis. We don't usually perform analysis for non-Winterthur collection materials, but we make an exception when other institutions have agreed to contribute data to the Poison Book Project. The Victorian obsession with brilliant greens is well documented. Arsenic-based pigments could be found in everything from apparel to toys to packaging to home decor. Consumers couldn't get enough of this vivid green hue, even as doctors and consumer advocacy groups circulated warnings about associated health risks. Emerald green was simultaneously being marketed as a rat poison and an insecticide. So there was a lot of confusion and debate at the time over arsenic's use in domestic products. Many people believed arsenic was beneficial taken in small doses, even as reports of accidental poisonings mounted in the press. While there are many contemporary newspaper accounts of accidental poisonings caused by emerald green wallpaper and wall paint, I have found only a singular instance of poisoning by arsenical book. A child in New York used an emerald green book as a watercolor palette and ingested arsenic, most likely when using his lips to form the paintbrush bristles into a point. Children and pets may behave unpredictably around books, but we can assume that the majority of adult library staff, library patrons, and book collectors will not lick their books. So what kind of risk do emerald green bindings actually pose? To better understand toxic book cloth in context, we consulted health and safety professionals in a number of adjacent fields. From the perspective of toxicology and forensic pathology, the risk of death from ordinary handling and use of emerald green bindings is very low. Understanding the risks gets a little more complicated from the epidemiological perspective. Different people have different degrees of sensitivity to inorganic arsenic, and chronic exposure is difficult to measure. One person may experience tingling in the fingers and then fully recover. Another may develop serious long-term health conditions that affect various organ systems. Our industrial hygienist colleagues have expressed the greatest concern about inorganic arsenic in library collections, and we are grateful to them for helping us figure out general health and safety guidelines for the storage, handling, and conservation treatment of emerald green book bindings. At Winterthur, we house our arsenical green books in zip-top polyethylene baggies. If any pigment sheds from the book cloth, the zip-top seal keeps it contained. The books are protected from water in case of a disaster scenario, and we can easily see the binding without opening the bag. The bag is also easy to label with warning and handling precautions. We recommend minimizing the need for library patrons and staff to handle arsenical books by using digital surrogates whenever possible. Wear nitrile gloves to handle emerald green books and wash hands immediately afterwards. Take care to avoid ingestion or inhalation of pigment dust. You may not see any loose pigment dust, but it's there. So avoid touching your face, eating, or smoking until you can wash your hands, even if you've worn gloves. Make sure bindings are used only on hard surfaces, which can be wiped down with a damp disposable cloth. This diagram represents a view of a case-bound book from the bottom edge. The green line represents the book cloth covering the case. This type of binding is particularly vulnerable to splitting along the joints, an area shown here with the red arrows. And in fact, this is the damage suffered by Winterthur's copy of Rustic Adornments. The case had split at the joints, causing the spine and the boards to detach from one another. A common repair for this type of damage requires lifting the original cloth away from the underlying board in order to insert new repair material underneath. The original cloth is then laid down and adhered over the new covering material. As you can imagine, flexing the cloth in this way can cause a friable emerald green pigment coating to spall unpredictably from the surface of the cloth, creating a much higher risk of arsenic exposure for the conservator. The use of wet adhesives can also cause arsenic to migrate and offset in higher and unpredictable concentrations. If interventive conservation treatment must be performed on an emerald green binding, then conservators should work under a certified chemical fume hood while also wearing PPE such as a lab coat and nitrile gloves. A second choice would be to work in a ductless particulate hood with a HEPA charcoal filter or glove box containment chamber. Wearing a respirator and working outside a contained environment should be considered only as a last resort. In January 2022, Rosie Grayburn and I founded the Bibliotoxicology Working Group. This is an ad hoc international cohort of about 35 conservators, cultural heritage scientists, librarians, book historians, and health and safety professionals, all interested in potentially toxic books and library materials, whether the source is a toxic pigment, a pesticide treatment, or something else. The goal of the group is to develop safe and reliable methodologies for identifying toxic components of historical book bindings and archives materials, and to define best practices for managing library collections. We post project updates on Instagram using the hashtags Poison Book Project and Bibliotoxicology. You can find project information, safety recommendations, and the frequently updated Arsenical Books database on our wiki. To request an emerald green bookmark, please email your postal address to reference@winterthur.org with emerald green bookmark in the subject line. I'd like to express my gratitude to our ever-growing research community for supporting and contributing to this work. Thank you.